Welcome to this explainer, where we completely decode Cambridge AS and A-level mathematics. Today, we're adopting a radically different approach. I call it the time traveler strategy. Now, what exactly does that mean? It means you need to see your completed, absolutely perfect exam paper before you even pick up your pen. We are going to work backwards from success. Specifically, we're zeroing in on the theoretical foundations and the strict technical methodology of Syllabus Section 9709, Topic 3.8, Differential Equations Using Initial Conditions. But to really understand the challenge ahead of us today, I want you to picture something. Imagine a dynamic split screen right in front of you. There's a ticking timer counting down and tension-building music playing in the background. This is the reality of the exam room. On one side of the screen, we have Alex. Now, Alex is a hard worker. He overloads his answers with raw mathematical facts. He dives straight into complex integration without any structured analysis whatsoever. It's just a wall of numbers. On the other side of the screen, we have Sam. Sam's completely different. Sam constantly rushes. He's trying to beat the clock, and because of that, he completely misses the subtle command word requirements hidden in the question. When we take a look at a real Cambridge mathematics past paper question, even going back to foundational codes like 0580 to build up to this level, and we put their flawed answers side by side, it is eye-opening. They are covered in red pen marks. And here is the secret. The difference between their current frustrating grades and an A star isn't their raw mathematical ability. They both know how to integrate. It's their strategy. They are failing the game, not the math.
Okay, let's map out our playbook for today's explainer. First, we'll tackle the core principles. Second, we'll outline the procedural framework. And finally, we'll dive into critical analysis and examiner traps. Let's get straight into it.
I want you to read this quote. A senior examiner specifically noted in their reports that while many candidates struggle with interpreting complex texts and data in this topic, understanding exactly what is being assessed literally changes everything. Think back to Alex and Sam for a second. When they face a differential equation, let's say it's separating variables for a population growth model, they bleed easy marks. It's tragic. Alex, in his rush to just do the raw calculus, might entirely forget the constant of integration. He completely ignores the initial condition that the question handed to him on a silver platter. Sam, on the other hand, might actually remember to find the constant, but then he fails to substitute it back into the equation to explicitly express y in terms of x, which is exactly what the command word demanded. So they both do the hard math, and they both lose the points. But after you finish this explainer, you absolutely won't be one of them. You're going to see exactly how to structure your math answers so they align perfectly, 100% with the examiner's marking scheme.
Part 1. The core principles. You see, the syllabus specifically targets 3 distinct cognitive domains, and it demands that you demonstrate your mastery through clear, evidence-based reasoning. First, knowledge and understanding. Look, this is simply knowing how to integrate. It's the baseline. Second is application. This is correctly substituting your initial conditions, your initial x and y values, to find that elusive constant c. But the third domain, analysis, that is exactly where candidates like Alex and Sam fall apart. Analysis is interpreting what that specific abstract equation actually means for the real-world model given in the question. It's evaluating the limitations of the data. It's setting up the equation correctly from a dense word problem before you even start doing the calculus. If you don't nail the analysis, the knowledge and application don't even matter. Before we continue and I show you exactly how to structure your analysis, subscribe to our YouTube channel, Ace the Exams, at acetheexams_IGCSE to excel in your Cambridge examinations. Click that subscribe button and hit the bell icon right now. All right, let's look at how top students handle this analysis requirement by breaking down the command words using a very specific framework.
This brilliantly illustrates what the Cambridge syllabus calls connected understanding. It's an essential skill. It's where top-performing students successfully apply causal relationships to entirely new, totally unfamiliar scenarios. To master this, top students structure their mathematics answers almost like an essay. I know that sounds crazy for a math exam, but they use the Peel framework, point, evidence, explanation, link. Let's do a quick 30-second mental timer challenge right now to see this in action. Ready? If I give you a differential equation about the rate at which a liquid cools over time, how do you apply the Peel framework? Well, your point is identifying the correct mathematical model, something like Newton's law of cooling. Your evidence is the actual mechanical separation of variables and the integration process. Your explanation comes when you substitute the initial temperature at time 0 to find your constant. And your link? That's connecting it all back to the specific context of the question by formatting the final equation exactly as requested. Top students don't just see a jumble of numbers. They see this connected framework applying to any unfamiliar context the exam could possibly throw at them.
In fact, principal examiner reports consistently highlight that candidates who explicitly reference cross-topic connections achieve significantly higher marks.
Listen, Section 3.8 does not exist in a vacuum. It connects heavily to integration techniques, partial fractions, trigonometry, and even logarithms. Whether you are building foundational skills from syllabuses like 0606, 4024, 4037, or 4040, all of that feeds directly into 9709. If your differential equation requires integrating a really complex algebraic fraction, you need to seamlessly transition into partial fractions without missing a beat. This is what we call the mathematics success blueprint. You aren't just solving a single, isolated topic, you are harmonizing multiple areas of the entire math syllabus into one flawless, cohesive, undeniable answer. You're showing the examiner that you see the whole board.
Part 2. The procedural framework.
So the crucial takeaway here is the method mark strategy. This means examiners are actively looking to reward your analytical framework and your clear notation. In Cambridge 9709 mathematics, method marks, which are denoted as M marks on the mark scheme, are your ultimate safety net. You earn these simply by showing the correct procedural process, even if you make a silly minor arithmetic slip that messes up your final answer mark, the A mark. Think about Sam again. Sam always rushes. If he skips the explicit step of substituting the initial conditions and just scribbles down a final guessed answer, he scores absolute zero. Nothing. But if he takes a breath and writes out the substitution clearly, showing exactly how he evaluates the constant C, he secures those method marks. You have to realize that your working out isn't just a scratch pad for your brain, it is a formal communication of your procedural logic to the examiner. You are proving your case.
To lock in these method marks every single time, you absolutely must follow this standardized 5-step sequence. Step 1. Deconstruct the question to extract your data. Step 2. Select your framework. Ask yourself, are you separating variables here? Step 3. Execute with crystal clear notation. This is where you integrate and immediately, instinctively add plus C. Step 4. Verify your results by carefully applying the initial conditions to find C. And Step 5. Present the final specific solution in the exact format requested by the command word. I want you to imagine a visual timer on the screen right now for 60 seconds. In that 60 seconds, imagine Alex rewriting his initially chaotic, messy answer. Watch the transformation. He isolates the variables. He integrates both sides clearly. He explicitly writes out his substitution of time equals 0, and he solves for the constant. The red pen marks literally transform into green check marks. Boom, maximum marks achieved just by following the steps. Stop scrolling. Subscribe to our YouTube channel Ace the Exams at Ace the Exams IGCSE to excel in your Cambridge examinations. We've helped thousands of students improve by 2 to 3 grade boundaries. Join them right now by subscribing to at Ace the Exams and IGCSE and turn on all notifications so you never miss our weekly exam strategy sessions.
Now, during that final presentation step, Step 5, remember that your practical application must strictly adhere to specific conventions. You're communicating like a mathematician now. Following presentation conventions is what separates a good student from a truly great one. For example, using the exact variables given in the text. If the question uses n for the number of particles and t for time, you must use n and t. Do not fall back on a generic y and x just because that's what you practiced with. If you give them y and x when they asked for n and t, you are throwing away easy format marks. It's tragic and it's completely avoidable.
Part 3. Critical Analysis and Examiner Traps. Let's get into the interactive workshop. When we evaluate evidence quality, we see a stark, glaring contrast in evaluative thinking between average and top candidates. We are going to do an interactive workshop right now. Challenge 1. The data scan. I'm putting a 60-second visual countdown timer in your mind. Look at the complex data source, the downward curve on the graph presented here. An average candidate panics and just blindly plugs the very first data point into their equation. But the top-scoring candidate, they extract the core trend. They notice that as the x-axis extends, the line approaches a specific limit, an asymptote, giving them a vital hidden boundary condition that the average student completely missed. Now for Challenge 2, find the flaw. Listen closely to this sample working and see if you can spot the flaw. Integrate both sides. Get y equals e to the x plus c, therefore y equals e to the x plus 5. Did you spot the sentence losing marks? The examiner commentary would heavily penalize this. Why? Because the constant c was incorrectly treated as a simple additive constant outside the exponential function, rather than correctly being an initial multiplier. It should be y equals a times e to the x. One tiny slip in algebraic rules and the whole model falls apart.
Top-tier students secure those maximum points because they don't just solve, they actively identify limitations and assumptions. They consider alternative interpretations, and they evaluate how these actually affect their final conclusions. Let's jump into Challenge 3, speed writing. Imagine a 30-second timer counting down on the screen. I want you to write one perfect, peel paragraph explaining your mathematical result. You wouldn't just write y equals 5e 2x and drop your pen. No. You would write, the population p at time t is modeled by p equals 5e 2t. This decision is justified by the initial condition p of 0 equals 5, but it assumes unbounded infinite growth, which is a severe limitation over a long period of time. Do you see the difference? That level of evaluative thinking, that real-world analysis, is exactly what Cambridge examiners are absolutely desperate to see on your paper.
Now please take serious note of this direct warning pulled straight from principal examiner reports. Never ever assume the examiner knows what you mean without precise definitions. Candidates consistently confuse key terminology. The biggest trap? Mixing up general solution with particular solution. A general solution still contains that arbitrary constant of integration, c. It represents a whole family of curves. A particular solution is the specific single curve you get after you use the initial conditions to find the exact value of c. If a command word asks for a particular solution and you leave the c floating around in there, you lose the final formatting marks. Read the command words.
To absolutely safeguard your grade, you must actively avoid these top 3 sequential mistakes highlighted by examiners. This timeline right here represents exactly how a student's paper unravels in real time. Step 1. Applying the wrong approach. This is failing to separate the variables algebraically before even attempting to integrate. Step 2. Neglecting your presentation and format checks. This looks like leaving natural logarithms in your final answer when the command word explicitly told you to express y explicitly in terms of x. Step 3. Providing generic answers that ignore the specific given context. For example, giving a negative time value as a valid answer when the real-world context of the model demands that time must be a positive value. By recognizing this timeline of disaster, you can build a time management matrix. This gives you the final piece of the system: command word decoding, Peel framework application, and your time management matrix to check your work against these specific traps before you hand your paper in.
As you prepare to practice past paper questions, I want you to keep the time traveler strategy in mind. Ask yourself this one crucial question to ensure you are truly mastering differential equations. Are you just finding the answer, or are you proving the method? Remember to decode those command words, apply your structured Peel analytical framework, and manage your time to check against those common examiner traps. Don't just solve the math, prove your logic. Students who implement these mathematics strategies see an average improvement of 2 grade boundaries, but only if they practice consistently with our weekly videos. Here's your final reminder. Subscribe to our YouTube channel, Ace the Exams, at @acetheexams_IGCSE to excel in your Cambridge examinations. Subscribe right now to @acetheexams_IGCSE and click that bell. Don't let another exam pass you by. Drop a comment below with your target grade for mathematics and the biggest challenge you're facing. Our team responds to every comment. Like and share this video with a study partner. Ace the Exams, your Cambridge success starts here.